Hi everyone, it's Stephen Daly here, and today we will discuss consensus protocols that are the base of the blockchain technology. Andrea Delaval from the Proof of Identity is joining us for this discussion. Hey, and welcome to our channel, Andrea.
Hi, thanks, Stephen. Hi, everybody.
Excellent. So, Andrea, can we start with what is the consensus protocol in blockchain?
Blockchain technology means to run application on an open and permissionless network made of a multitude of servers, each of them doing the same thing and coordinating with each other to write each block in the same way. This involves the creation of rules which assign voting power to participants and so prevent attackers from gaining control over the open network. All these rules that assign voting power and coordinate the servers of the network make the consensus in blockchain.
It's very interesting. So, the consensus is the set of rules which determine the protocol for participation in the network. So, if we start with the most common and criticized consensus, the proof of work, the consensus of Bitcoin, you might tell us how that works?
Sure. In the proof of work, participants acquire voting power and associated rewards, which are mining rewards, according to the amount of hash rate their machines are able to generate. Hash rate, in simple terms, is equivalent to the energy wasted by these machines.
So the participants are machines, and the more energy they waste, the more voting power they receive. And is this computational power needed to solve the cryptography of Bitcoin?
Not really. Not to the extent that that is necessary for any purpose other than providing the genuine commitment of the participant in the blockchain. In the proof of work, the waste of energy is directly incentivized by the level of reward received, a value that is strongly correlated to the market cap of the blockchain. The more the blockchain is capitalized, the more the energy wasted.
I see. And in today's climate, everyone is talking about climate change. It's a big topic. That sounds very environmentally unfriendly.
Yeah. In fact, carbon footprint is a whopping 100 million tons of CO2 per year, while very disappointingly, the network is controlled only by a handful of entities. That means the Bitcoin mining is wasting and producing an horrific footprint, but doesn't achieve decentralization at all.
It's not good to hear. So proof of stake is different. How does that work? It's not based on hash rate. So that, in theory, should be much more environmentally friendly. Is that correct?
Yeah, that's right. In the proof of stake, voting power is assigned according to the quantity of stakes owned in the network. In general, that is the amount of coins owned by the participant in the blockchain. The idea is that if you own a lot of coins in the network, you will not be interested in damaging it, but instead you would behave correctly to preserve its integrity. This easily sounds a great remedy to many people, yet proof of stake carries along two big problems. Problem one, the network becomes quickly populated by big corporations that acquire a lot of stakes, and so the control of the network. This effectively prevents the blockchain from achieving a decentralized network. And so it is enough of a reason to scrap the idea. Problem two, individuals' participation is minimally incentivized, as rewards for them are also very minimal. This penalizes the adoption of the blockchain significantly. Even if there are many forms of proof of stake, the intrinsic problem of this protocol stay the same, and in some cases get even worse. For example, it comes to my mind the Filecoin. In the Filecoin, voting power is assigned according to the amount of storage each participant adds to the network. That sounds very appealing to individuals owning a PC, but it's not difficult to see that eventually big cloud companies will gain full control of the network, and while also benefit of the consolidated market. Overall, proof of stake does not waste energy, but does not achieve the goal of blockchain either. So it's definitely deserved to be scrapped.
I think you've made a lot of really good points in that. I think I would agree. So we often hear proof of elapsed time and the proof of authority. Can you explain those a little bit more to us?
A proof of authority network is a permission network, meaning that a central authority gives permission to others to participate. This is outside the concept of blockchain as per its definition. So in my opinion, people talking about it in this particular context generally have limited understanding of blockchain. Proof of authority is generally used by enterprise networks, which have servers spread all over the world that need coordination. The proof of elapsed time is effectively a proof of authority in which the time the participant has spent in the network is also taken into account to assign his voting power. It's a concept that maybe can have some application, but it seems clear to me that cannot be taken seriously in blockchain.
Very good. So next in the pipeline are proofs based on individuals. And for those, I guess it's easy to get a little bit confused because generally you hear the same claims from very different blockchains. Can you give us some clarity on different types of proofs based on individuals?
Yes, thanks. With proof of work and proof of stake, we saw the category of proof of investment, i.e. participants invest in some activity or resource to prove their genuine participation and acquire voting power. That carries along a lot of criticism and ultimately does not achieve decentralization and censorship resistance. So those protocols make blockchain meaningless, a nonsense network wasting the resources for no reason. So the most logical and democratic way to assign voting power seems to be using the same method we use in our democratic society. Everyone gets one and only one vote. But now again, we have another problem. How do we make sure that everyone is counted only one? And to achieve this goal, there are a few different approaches. Approach number one, social recognition. Here, many have attempted to propose a mechanism in which the interactions between participants, or even in some cases their presence in the social network, should guarantee the humanity and uniqueness of the participant. This might be okay for a banter blockchain, and in certain cases could even guarantee the resistance against cyber attacks, but it's clearly not fair and secure enough to consolidate a blockchain upon. Then we have second approach, proof based on captcha solving. Well, first, they are very, very boring, and as they require the solving of captchas as a proof. And they are not even secure, as we don't know whether artificial intelligence engines would be able to solve captchas in the future. So moving on, the third approach is the proof of personhood. This is what inspired the creation of the proof of identity. However, in the proof of personhood, pseudonymous parties are organized so that individuals can prove their humanity at the meeting and receive 1 unit of voting power. Proof of personhood sound simple and great, but as data of individuals are not recorded, participants have to attend again and again new parties every time the network expands. And new parties are organized in different regions in order to avoid multiple attendances. So let me make a short example. If a blockchain based on proof of personhood starts in London and they organize a pseudonymous parties, then the people from Liverpool might want to join. And so the blockchain will have to organize again one party in London and another one in Liverpool. And once the people from Birmingham wants to join as well, then we would have to organize again one party in London, one in Liverpool, and one in Birmingham. So the process becomes, you can see how the process becomes endless, discouraging, and ultimately able to cover only a part of the population.
For sure. I mean, who has time to go to so many parties, right? We're all busy.
Exactly, exactly. And if you think about it, even if everybody fancy to attend this party, there will be always a certain intake of the population who won't be able to do it.
Of course.
People working as a doctor or a policeman or whatever, right? So it basically it's something that it never gets to a real end. It keeps calling people to this pseudonymous party. Nevertheless, the idea is really, really cool. You just attend a party and you are given a unit of voting power. So that is what inspired the proof of identity. And now we have the fourth approach. So proof based on biometric identification. And the proof of identity belongs to this category, obviously. So biometric proof aim to identify uniquely one individual and then store his data in the blockchain. So there is no need of multiple attendances like we saw in the proof of personhood.
It's very interesting, Andrea. But proof based on biometric identification, I mean, they're not all the same. Can you tell us a little bit why proof of identity is, in your opinion, the only one achieving in full all of the goals, and where the other ones might fail a little bit in comparison?
Sure. So proof based on biometric identification might be able to achieve, in some cases, the goal of identifying uniquely each individual. But that's not still enough to make the blockchain we want. Because it's fundamental in blockchain, the absence of a controlling authority. Otherwise, we create again a centralized system. For example, blockchains like the WorldCoin or the Good Dollar fall into this group. They fall again into systems in which their organization have to be trusted in order to ensure the fairness and the security of the system, simply because the biometric procedure is controlled by this organization. The proof of identity network is the only consensus protocol able to uniquely identify individuals, assign them one and only one unit of voting power without having a central authority taking part in the process of identification. The proof of identity, so, is the only methodology among biometric-based proof ensuring fairness, security, while remaining fully trusted. And so it's the only consensus protocol achieving in full the goals of a decentralized blockchain.
Some very interesting stuff in there indeed, Andrea. Thank you so much for this explanation of consensus protocols. Looking forward so much to the next episode. But for now, take care, stay tuned, and remember to click and subscribe and like and support our channel as well. Take care. We'll enjoy the rest of your day, and we will talk to you very soon.